and it's a great pleasure to welcome to the lecture series Justin Den Herder, our residents who are currently in the architecture residency program under the theme Resonance will introduce Justin and moderate the conversation. Thank you, Simon.
Hello, everyone. I'm Simon Han. It is my pleasure to introduce today's lecturer, Justin Den Harder. Justin is a structural engineer at TY Lin Buildings, where he has worked on more than 500 projects with a focus on adapted reuse, mass timber, and civic and cultural architecture. He also helps lead the firm's sustainability and building equity initiatives. Beyond engineering, Justin is a poet and an educator. He teaches structural poetics at Cooper Union, a course that explores how efficient, elegant, and equitable structures can improve the built environment. Earlier this year, he published his first poetry collection, Welcome Center. Please join me in welcoming Justin Den Harder.
This is where the applause comes in. No, it's a joy to be here. I'm coming to you from my office in New York City. Saw some floating hands, nice. Where I work at TY Lin as a structural engineer, as you've heard. But over the course of my career, I've had the privilege of working on, I think now a dozen, as last count, dozen projects with Stephen Hall and his team. And I've learned a lot about architecture, architectural thinking, and the philosophy behind architecture through those projects and those interactions. So it's definitely an honor to be here. I have a lecture and some slides, so I'll share my screen and dive into it. And feel free to ask some questions in the chat, and happy to facilitate be part of a discussion after the fact as well. I'll talk more about the project on this title slide a little bit later on, but I think this photograph represents how I want to think and talk about the theme of your residency, resonance, today. This presentation is, as I see it, about the resonance between ideas and different ways of seeing and being. And this resonance today, I'm talking through the ideas behind structural poetics, which is a kind of an ethical, philosophical approach to architecture and structural engineering. I want to just start by reading a little poem. This is called Tower Cranes. To what will we bend, and to what end? What will placate our hate? What will satiate? When tower cranes crowd the Serengeti, when strip mines blacken our last lung, oh, the soot of time we're trudging through. Minutes after dawn, the future arrives on a flatbed truck. Reflective vested and hard-hatted, the flagman's octagon flips from slow to stop. From the street, I watch crates of tomorrow stacked, lashed, and rigged. At somebody's signal, it's lifted and lifted into another sky. I wrote this poem to kind of capture what I was learning about how we currently build and the impact that it has on the planet, and kind of the seemingly reckless abandon that we see in this approach. But it's important to not stop there, right? This little sketch of the tower crane shows that we're actually the ones in the driver's seat, and that we have agency in dictating what the future of architecture is. So I want to give us the right context for how we're currently building and how the effects on the state of the world, but also offer a vision and a future that is a bit more abundant, and kind of the notion of structural poetics is an ethical approach to help guide us through some of these challenges and offer a different way of seeing. So where are we right now? This is a graph from an article from Nature magazine. In 2020, the human-generated mass of everything that we make on this planet exceeded the biomass of every living thing on the planet, which is a remarkable stat, especially considering that the total density or mass of human-made objects in 1900 was only 3% of biomass. What this means is that we are creating and using resources at an alarming rate. At this rate, as shown on this graph, by 2040, anthropogenic or human-made mass will be triple biomass. This is an exponential curve, right? And the rate at which we're using materials on a finite planet is astronomical. A huge component of human-made mass goes into buildings and infrastructure. If I flip back to this curve, you can see the blue and purplish colors make up the majority of this mass. These are constituents that go into our buildings and our infrastructure, essentially sand, aggregate, concrete. And seemingly those are in abundance on our planet, but the Earth's crust is finite. And actually, the UN Environmental Program has issued warnings about a sand shortage. If you can believe it, the material that throughout human time has metaphorically represented eternity, we're running out of it. So we need to imagine new ways of building and constructing architecture. The human species, the population continues to grow at a global scale, and humans have need for shelter, for architecture, for buildings, for infrastructure. So therein lies the paradox that we are on a finite planet, human population and human needs are growing. So wherein lies the solution? We will talk a bunch about renewable materials, renewable construction materials, and structural materials, but we need to go deeper than that. We need to start someplace deeper than that, in my opinion. We need to begin with kind of an ethical scaffolding from which these ideas can flow out of, because many of the philosophical underpinnings about what it means to be successful, what it means to create successful architecture, those lines of thinking, in many instances, there are exceptions. I think of indigenous cultures that have planned and built architecture and communities within their means and local resources. But on the whole, much of the constituents that of which architecture is comprised have led us to this point where we are doing detrimental harm to the planet. So if we think about this, what is a proper framework? What is an ideal that we can rally behind collectively to help turn this ship around? And I do think it can be turned around. And that's the primary focus of today's discussion on resonance. An ideal is just that. I'm not naive enough to think that any individual can throw one idea out there that is going to turn this ship around. But I do believe that resonance or coalition of ideas that we can have buy-in collectively can help get us there. And structural poetics is an ideal for us to strive for, knowing that it can never be achieved perfectly, right? But that is an ideal that can guide our hearts, minds, and hands towards a new future, keep us curious and learning. And within that act of reaching for an ideal, there is purpose. So this is how I would define poetics. Poetics in this instance, I categorize and describe with 5 attributes. The attributes you see on the screen: efficiency, economy, elegance, ecology, and equity. Efficiency, economy, and elegance are usurped or taken from David Billington, who's a well-known structural engineer who taught at Princeton for many years. He wrote a fantastic book, which I have behind me, called The Tower and the Bridge. And he defines structural art as human-made structures that have efficiency, economy, and elegance. I read that book and was thinking some about the place that we're in right now as a race, and thinking that that doesn't quite get us there, that we need to also add to those 3 attributes ecology or environment, our place in the broader realm of nature, but also equity. Are we building and fostering community, or are we building towards isolation? No building is an island, an individual work of architecture, you could say. And I use the term poetics partially because of my love and passion for poems, but poetics is really meant to represent transcendence of ideas across medium. I just want to read something from the writer Teju Cole, so a writer whose work I cherish on the term of poetry or poetics. This is from his book Blind Spot, which is a photography book with some essays, kind of as the caption or accompaniment to the photographs. He says, more than the work itself, and he's referring to Russian cinema in this instance, its form, its genre, its existence, intangible form, what interests me is the secret channel that connects the work to other work. Tarkovsky, a Russian filmmaker, calls it poetry. This link that allows different kinds of excellence to understand one another. I think this is the best word we have for it, although that very word poetry is in English debased and sometimes taken to mean the mere communication of sentiment. Nothing that remains solely within its genre succeeds as poetry. When I make a work, no matter how small, no matter how doomed to be forgotten, its only poetic possibility interests me, those moments in which it escapes into some new being. If everything else succeeds but the poetry fails, then everything has failed. Poetry is precisely that which can be translated in higher, or perhaps I mean inarticulable, realms. When one encounters these diverse forms of poetry, there is a certainty that they are mystically related one to another. Everything is there, everything except the proof. So a structurally poetic work is one that connects with these 5 broader attributes. This can be achieved through our material choices and their supply chains, through elegance of the arrangement of the material and their connections and detailing, or the ability of that arrangement to support various different functions within the space that they hold and create. Structural poetics is thriving when collaboration is thriving. And it's been a joy of my career to witness sharing and support that is founded on diversity, teamwork, and technical expertise. Thriving collaboration depends on generosity and curiosity. I know you all are working independently on projects for your residency, but as you move on in your career, it's really the seeking out of collaboration where the magic happens. I just want to also state that that goes beyond just the design team. I've had many wonderful conversations with contractors on site, and I'm always curious as to how they would have detailed something differently. There's a lot that can be learned from the folks on site that are actually putting together and making your dream a reality. So today I want to tinker with this notion of poetics through three primary categories. This diagram's kind of showing the resonance between these three ideas: tree, structure, poetry. So let's start with tree. I walk around Brooklyn and I see the amazing trees that line the streets in my neighborhood. And I've come to, as I understand and learn more and observe more, to understand trees as idealized works of architecture. Said differently, I think every architect is striving to design something as wonderful as a tree. There is no wasted material in a tree. The form and the function are united. They are one and the same. Each element and aspect of a tree is serving multiple purposes, multitasking, right? I just want to touch on a few things that I've learned here. This is a sketch that represents an initial observation by Leonardo da Vinci, and others have expanded on this. This is often called the law of branching. And trees grow in a fractal pattern, and many folks suspect that's why trees are so appealing to the human eye, because we're drawn to fractal geometry. But what is interesting as kind of a structural concept is that if you look at the circumference or the cross-sectional area of the tree trunk, and then you were to cut a radial section above the tree trunk where it starts to branch, right? Obviously, the branches get smaller and smaller in diameter as you get towards the twigs at the very edge of the tree. But if you were to sum up, for example, all of the twigs and branches that cross this line at a certain distance away from the tree trunk, the sum of those circumferences equals the circumference of the trunk. And that is true at every kind of radial cross section that you cut. So what does that tell us? Well, this relationship has to do with the flow of fluids and nutrients through the trunk, or from leaf to root, essentially. You can think of these as a network of conduits or pipes within the trunk. So there's a remarkable geometry at play. And tree trunks are often kind of represented as circular elements. But when I walk down the street in Brooklyn and I look at the trees and I think about how the wind might be funneling down the street, you actually see that all tree trunks are elliptical, and they grow that way, and they're shape shifting over time to reduce wind drag and surface area, because the main goal of the tree is to aspire upward and reach for the light and not be blown over in a windstorm, for example. So there's a beautiful structural and architectural concept hidden within that. If we look at different trees and how they branch, This is taken from a book called How to Read Trees by Tristan Gooley. Wonderful book. That's a great accompaniment if you're going for a walk in nature and want to study trees as maps of the landscape, maps of wind patterns. There's many wonderful things to learn. But this is my replication of one of the sketches from his book. But you can see the different ways in which trees naturally form moment connections when they branch. And these are the two different ways that we would develop moment connections in a building, obviously in a slightly different form. But this makes me think that trees are the most incredible 3D printers on the planet. What's more is that if we expand beyond the individual tree, we begin to, and we look deeply. I want to touch on a study by Dr. Suzanne Simard. She is a PhD and professor at the University of British Columbia, and her findings, modern findings, revolutionized our thinking about how a biodiverse, thriving forest works and how trees of different species communicate with one another and share resources. In 1997, it's about the time that the internet entered my family's home when I was growing up and in middle school, dating myself a little bit. This article and these findings were published in Nature magazine, and the title of the article was The Wood Wide Web. Essentially, Dr. Simard's a series of experiments that involved the insertion of carbon-13 isotopes into individual trees that were isolated, essentially protected in their individual tree planters or pits. Over time, it was observed that carbon-13 isotopes appeared in adjacent trees, even though there was no apparent connection between them. And what the findings came to uncover is that there is a mycelial network underground in the topsoil that connects tree root systems together, regardless of species. And that this mycelial network is in fact incredibly dense. If it's estimated that if you took the mycelium in the top 10 feet of topsoil on the Earth's crust and stretched it out as a single line, it would reach halfway across the diameter of the Milky Way galaxy. So this is an incredibly dense network of resource distribution, and that trees are actually constantly communicating in this manner as a form of resource distribution. And this is a graphical representation. I joke when I give mass timber presentations and I show this, that this would be my first tattoo. Haven't made that leap yet. But this is a graphical representation of the interconnectivity of a grove of, I believe, 47 trees through one of Dr. Simard's graduate students' research. So the most highly connected tree is what Dr. Simard calls the mother tree. And in fact, her autobiography is called Finding the Mother Tree. It's a really beautiful book that was quite inspiring to me. The mother tree is typically the oldest tree in the grove, old growth tree, and does a lot of the management of resource distribution. Thus, why it's so vital that we maintain old growth trees. We've cut many of them down, but they must be protected because they play a pivotal role in trees growing in a resilient and healthy manner. The last point I want to make on trees is understanding that context of the interconnectivity of trees and the importance of old growth and biodiversity in a thriving forest. I want to make the leap: if an individual tree is an idealized work of architecture, then a thriving forest is a representation of an idealized city. Biodiversity can come to represent diversity of many things in city, diversity of culture, economic diversity, the infrastructure, so-called natural infrastructure of a thriving forest, mycelial network, is obviously a fantastic metaphor to our infrastructure below city streets in terms of sewer systems, transportation networks, and all the rest. So I really think it's important that we look to forests not just as a resource, but as an actual model for urbanization. I sometimes wonder if individual trees in tree pits in my neighborhood feel like they've moved out to the suburbs. So forest is really a metropolis of trees. Poetry. This I know Stephen is a big fan of W.S. Merwin and Copper Canyon Press. I know he's supported Copper Canyon Press. When I went to Crit at Columbia University and for a final review, and we went out to dinner afterwards, I had a copy of my W.S. Merwin book. And Stephen said, "Why don't you look in the cover?" And I saw his name as one of the donors for the book. This is a poem by W.S. Merwin, who's a well-known poet, but what is less known is that he purchased 18 acres of land in Maui on a decimated former pineapple plantation and spent this entire second half of his life um, uh, basically revitalizing that land and planting various different species of palms. And today, the Merwin Conservancy, Merwin died, I think 5 or 6 years ago, but the Conservancy lives on in his land or on his land that he worked with his wife Paula. And it's a beautiful model because he planted all of these palms. He and Paula planted all of these palms by hand. And the extent of the palm forest, which now is a world-renowned palm forest, and biologists from all over the world go to Maui to study the palm trees on his conservancy. And this was done in a single lifetime. So it's a remarkable legacy of stewardship. And the extent of that forest were basically how far William Merwin could carry a bucket of water. Or at least that's the legend. Here's the poem. All day the stars watch from long ago. My mother said, I am going now. When you are alone, you will be all right. Whether or not you know, you will know. Look at the old house in the dawn rain. All the flowers are forms of water. The sun reminds them through a cloud, touches the patchwork spread on the hill, the wash colors of the afterlife that lived there long before you were born. See how they wake without a question, even though the whole world is burning. And I want to create structures and architecture that mimics the craft that goes into poems. So I think about structural systems, as odd as this might sound, in this manner. If we think about words or language as the material of poems, when I would go so far as to say when Merwin was creating this poem, every word is placed with intention, right? Every word is flowing out of individual experience. Yet when I read this poem, when you all read this poem or hear this poem, you are bringing your own experiences to this poem as well, right? So there is, in that, there is transcendence. And I believe that architecture works in the same way. Words are maybe not the material of a built work of architecture, but the structural system which is giving form to the architecture is creating a vessel for individual and collective experience. So the material that we use is as sacred as the words and their intentionality within a poem, right? So to me, the kind of attentiveness, the craft, the slowness of the creation of a poem has a lot to offer us in terms of how we think about architecture and, from my experience or from my lens, the structural systems that inform architecture. A building that I believe represents structural poetics is Kevin Roche's Ford Foundation building, which was built in 1967 on 43rd Street in Manhattan here. And these are some photos from the Ford Foundation building's website and their center for, it's now the Ford Foundation for Social Justice. Now, if you don't know of this building, the atrium that you see is at the base of a 12-story atrium, and these skylights are floating above that 12-story atrium. And you have this beautiful public plaza that is indoors, that is filled with mature trees and this reflecting pool. And it's a beautiful place for folks to go in and sit, especially on a day like today when the city is filled with smog from wildfires. To me, this kind of revolutionary design, this design around Corten steel, the granite, but also the glazed transparency of the office spaces being able to see each other across the atrium, the public being able to look through the glass and interact with folks in the atrium, the transparency of the building that allows the public to enter in. This was a revolutionary concept at the time when this building was created and opened up. I wrote a poem several years ago that I've called the atrium. Of course, this is the atrium architecturally, but atrium is also a structure within the human heart. So this is called the atrium. Right in the heart of the city, there's this built respite. Here the air is woven with welcome. Light-nurtured plants sing skylight praises. The reflecting pool ripples with coined constellations, the tossed gleam of our wishes. Here anyone can take a gardened break, stroll the bricked paths, or sketch a bench poem, whatever it takes to fend off the immensity, the cardiac chaos that cannot be corralled. Lay down your barricades, your bollards, your security checkpoints, and freely enter into this tamed paradise. This is the architecture of embracing. And the last part is structure. So now I want to tie this into architecture a little bit more intimately. I'm going to give a few thoughts about kind of laying the context for looking at poetics through a structural lens, and then give 3 project precedents and talk about how they come to represent this ideal in some form or reach for this ideal. Form facilitates function, right? We say this a lot, but the structural system is often the thing that is creating the form. So if you're creating a space of assembly, right, the structural system that you are going to choose is likely to be one that can span farther to create a more column-free space that facilitates gathering, right? If we're creating a performing arts center, you don't want to have columns obstructing views. Conversely, if you're building a dormitory for a university, there's a lot of repetition in the form, right? So the structural system that is best suited for that is perhaps going to be of a different nature. So we need to align form and the structural system that creates that form with the function of the space. The form controls the forces. There is a lot of efficiency in geometry and in symmetry. So if the function of the space allows for us to play with the geometric form, then there is efficiency, elegance, and economy that comes out of that. When the form is well chosen, or you could say well suited to the function of the space, the structural analysis becomes simple, which means that you are using the minimal amount of material to create that form. That's what we're striving for as poetic structural engineers. And I'd argue that's what we should be striving for collectively. This diagram is a classification of different structural systems based on how they redirect forces that are applied to them. This is taken from Heino Engel's Structural Systems book. A lot of really great, very Germany diagrams included here. So the five forms, the five classifications are form-active structures. These are structures, structural members in which the member is either fully in compression or fully in tension. The cable on a suspension bridge is a form-active structure fully in tension. A stone masonry arch bridge that was built 400 years ago is an example of a form-active structure that is in compression. A vector structure or vector active structure is your trusses. So your trusses are a combination of members, and at any given point when that truss is spanning and is experiencing external loads, the members that make up that truss are either in compression only or tension only. But taken holistically, they're in equilibrium, right? There are members that are in tension and there are members that are in compression simultaneously. Cross-sectional structures that are beam type elements, beam or frame type elements. Here, the truss is essentially compressed down into a beam. If you were to cut a slice through a beam along the length of its span and look at a diagram of what fibers are in compression or in tension, you would see something that looks like a hidden truss inside, hidden within the cross-section of the beam. So if the beam is loaded from above, your top surface is in compression and your bottom fibers are in tension, and those are coexisting within one element. A surface active structure is forces flowing through a surface or through a plate. So this is essentially a three-dimensional version of a form active structure. So a dome or a vaulted arch are good examples of axial forces flowing through the cross-section of a member in that flow in a manner that follows the geometry of the space of the form that you've created. This is very effective for long span structures, long span column-free structures, because you're using the benefit of geometry to gain efficiencies within your system. And the last is a height active structure. Now, this is a structural system whose chief mode of resistance is resisting overturning due to wind and/or earthquake forces. So how do we prevent a building from tipping over? The overturning moments that you experience at the base create unique challenges in height, buildings of height that you don't necessarily have, or you do have, but to a lesser degree in low-rise buildings of other forms. The first project I want to touch on is Franklin and Marshall College. This was a project that was completed during the pandemic. We worked on it with Stephen Hull's office starting in 2017. It's 32,000 square feet. This is a photo from Iwan Baan of the final result. And the architectural concept, as Stephen will tell you when you meet with him, was a box kite. Franklin and Marshall College is named after Ben Franklin. So the concept, the architectural concept here is a box kite that is up in the trees. And Franklin and Marshall campus has many beautiful trees. So I loved this concept, this rather poetic concept, I would say, of the perimeter of the building respecting the tree canopies. We developed a structural system that is a combination of different materials doing what they do best. So in orange, you're seeing, in orange and in yellow, you're seeing the cast-in-place concrete walls that form the lateral system for the building, kind of the solid core or the trunk of this canopy type building. And that's in compression, right? So concrete was very good in compression. So we utilize concrete at these cores. And then radiating out from those cores in the light blue color, we have these steel frame trusses. And steel is very good in flexure and in bending, and it's a very stiff material. So it's good at resisting deflection. So naturally, that was the best material choice to basically reach out to the perimeter of the building and hold up the floors. And then up on the roof, I'll get to a photo of that in a second. These are just some photos of our analysis model. This is the full building model in a program that we call ETABS. And this is from that same model. This here, you're seeing the steel trusses kind of reaching out to the perimeter of the building to hold up the facades. This beautiful drone shot taken from the contractor Poole Anderson, a local GC who did a fantastic job building this building. And you can see the architectural motif playing out in real life here in this aerial shot. Lastly, we integrated wood in the form of timber tongue and groove planks that basically functioned as small catenaries that created the curvature in between this curved steel roof skeleton that kind of functioned as the skeleton of this very light box kite type structure. And this wood framed roof was built by local Amish community, well versed in erecting and building wood frame structures in the region, and they did a fantastic job on that. This building was successful. It's a small gem, but there's a lot of complexity of detailing based on the geometry. And when I mentioned craft and poetry, that I hope to some degree we attempt to translate that over into our detailing on projects. And still hand sketching and sitting around a table and talking through these ideas, which in this case I did with Marcus and Carolina and Garrett from Stephen Hull's team. This was a key point to the success of the project. Despite the complexity of the curvature, we were able to get a uniform set of details to work around the perimeter of the building in spite of the complexity. That took something that looked rather complex and simplified it. And it started with hand sketching and collaborating. Of course, we need to also understand how a building is moving and behaving. From the photos, you saw this intricate facade that involved channel glass installed at certain parameters, and then other large glazed panels, and then sensitive plaster finish elsewhere. So we had to very closely collaborate with all parties on the project to understand how the building would move and behave at different points of construction to make sure that the glass at the perimeter doesn't inadvertently become a load-bearing element and crack in a windstorm. So these types of diagrams were very helpful. Here you're seeing obviously the deflection in very exaggerated form in these diagrams, but this was key to successfully installing the facade here. And then you're seeing the beautiful result from the inside looking towards the channel glass. I want to touch on this project, which is going to be complete very soon. This is at Amherst College in Amherst, Massachusetts. We're working on this with Herzog Demeron and Sasaki as the architects on the project. And we're initially brought on in 2019 to design a new mass timber student center. And on site, there was an existing structure called the Merrill Science Building. It was built in the 1960s. It was a giant cast-in-place concrete, post-tension concrete structure. It looked like this, like the photo you see on the left. As we developed a number of schemes and we learned more about Amherst College's desire to decarbonize their campus, we ended up proposing taking the mass timber student center that we're designing and putting it on top of the existing building to increase the square footage in the program, which was a bold suggestion, but the team went for it. So what we ended up doing is we took down the upper couple of partial stories. We took this down to a plinth level. We kept the existing concrete and put a new mass timber structure on top. There's the architectural model showing this scheme, and we're going to strip away the existing brick that was cladding and expose the original cast-in-place concrete structure as kind of a raw tectonic approach. This diagram shows just how much embodied carbon emissions were saved by keeping most of the existing building over against the potential new build. So on the left, you're seeing the tonnage of CO2 emissions that are required to build a new building of the same size. In the middle, you're seeing the student center with the physical volume of CO2 that we're keeping. And then in green, you're seeing the CO2 that's saved by keeping the existing building and using a low embodied carbon material for the vertical overbuild. So a 33% reduction in carbon emissions, and that isn't even including the CO2 that would be associated with the actual demolition process. So adaptive reuse combined with mass timber, which is a low carbon material that grows, by the way. Construction sand doesn't grow. Concrete doesn't grow and naturally occur. It takes millions of years for that to regenerate. Meanwhile, trees can regrow in a human lifetime. So the use and integration of renewable resources is really vital to the future success of achieving the ecology part of this idea of poetics. These, I'm just going to cycle through some structural diagrams that we created over the course of the project. Of course, in order to make a bold proposition like this, we need to do some engineering legwork. So in this instance, these diagrams that you're seeing are what we call a capacity map. On the left, you're seeing the found capacity of the existing building. The majority of the building had about between 10 and 25% additional capacity. But if we take off the upper stories and take it down to the plinth level, you see that much of the orange gets converted to green, which means that we now have a substantial amount of capacity on which to place the vertical addition. So this tells us a story about how we might place the massing on top of the existing structure to remain. And mass timber is a good material for this because of its relative lightness compared to other conventional structural systems. You see on the left, the scheme that we moved forward with, we built the vertical addition in mass timber. We only had to reinforce 3 existing column footings, whereas if we did the same analysis in steel or concrete, we would have had to reinforce many more footings. That's more material, that's more time, more cost, and more risk to the project, because reinforcing an existing foundation while the building's standing is not an easy thing to do. Our concept here was to basically take the existing structure down and use a transfer level of mass timber to create the transition between the new mass timber overhead and the existing concrete structure below. This became a critical detail on the project, and this is one of probably hundreds of sketches that our team did to try and represent different concepts of how the wood would meet the top of the existing concrete structure rather. And this is where we landed. So we essentially took the roof slab off. We cut the existing concrete columns flush at a consistent datum. And then we built our mass timber transfer level directly on top of that cut concrete column. And this was the result of hundreds of hours and many team members collaborating. Nordic Structures was a fantastic teammate on this project as the mass timber supplier and fabricator. But herein lies the challenge of adaptive reuse. You have an existing building that was built not perfectly. No building is built perfectly, right? And then over its lifetime, it becomes even more imperfect, right? So you are putting a theoretical perfect grid on top of an imperfect building that has shifted to some degree. So this detail, aside from its architectural and aesthetic appeal, is wrangling with some very difficult engineering challenges. So this detail is concealed, but it is reconciling the eccentricity or the out of plumbness of the existing columns, and we are landing hundreds of thousands of pounds on top of a slightly deviated structure. So these diagrams are kind of representing how these mass timber transfer girders were receiving an idealized column grid up above that is plumb, at least in our Revit model, and mostly plumb on site within acceptable tolerances. And then how that load is filtering down. And this detail is dealing with that eccentricity. Now, the magic of this detail is Herzog Demiron chose to oversize the glulam column, because if we tried to match in mass timber the exact cross-section of the column, then any imperfections or eccentricity are immediately apparent, right? The top becomes kind of divorced and not flush with the concrete column below to a degree. So oversizing it turned this from a glulam column extension to an actual capital-esque type feature, and allowed us to visually conceal that eccentricity, which in most cases was an inch or less in either direction. And that language actually became a detailing language for the all timber superstructure up above, where we had essentially timber corbels or timber capitals that were woven into the mass timber fabrication. And in the interest of time, I'm just going to cycle through some construction photos from the past few months. This is how things are shaping up on site. I think we're hoping this is open for the fall semester. We'll see. Opening ceremonies should be happening relatively soon. Beautiful views out to the Berkshire mountain ranges in the distance here. One last project. I just want to talk a little bit about the importance of the architectural scheme here. This is a new Brooklyn Public Library. It's in construction right now. It is a new mass timber structure. We're working on this with Mass Design Group and Marble Fairbanks as the architects. Gilbane is the contractor, and Timberlab is supplying the mass timber for the project. Now, the existing New Lots library, which doesn't suit the needs of the current community in terms of size and the condition of the library, in addition to the library being kind of obsolete from a service standpoint, it was uncovered or became understood that there are African American burial remains adjacent to this site. So Mass Design Group with Marble Fairbanks and input from the community wanted to, with BPL, of course, wanted to develop a scheme that was not only meeting the programmatic needs of the community with a beautiful, healthy, low carbon building, but that the design and concept behind it was one of community gathering and social justice and reckoning with the history of this challenging site. And the concept is based on the notion of palaver, which is a West African notion of a gathering or community space underneath a tree or a grove of trees where community issues can be discussed. Now, this is a diagrammatic version of the structural partie that developed out of this palaver concept. We have these two trunks with main branches radiating out. So this is the footprint of the floor. And here you're just seeing some additional diagrams of the structural system and rendering of the space. Again, we're actually reviewing the mass timber fabrication drawing, so hopefully we'll be able to see this in real time soon enough. And we, similar to the Amherst project, the columns and the tree-like nature of these radiating columns, the trunks of the palaver, were a primary focus of many conversations to make sure that they not only achieved the aesthetic appeal and desires of the project, but that they work structurally and that they could be fabricated in a cost-effective manner as well. This was part of a study that we did for the Economic Development Corporation of New York's Mass Timber Studio, which is a public program for which this public project was part of. And we reported out the embodied carbon of our design in mass timber over against other hybrids, right? So it's important, if we are to be part of decarbonizing the built environment, that we begin tracking how we're doing. And this shows how a mass timber system compares to a hybrid mass timber system or a steel and slab on metal deck system. And you can see that there's substantial embodied carbon to be saved here. And if I equate the volume of trees here to, or the volume of mass timber in this project to a mature Douglas fir tree that is 80 years old, there's about 200 mature trees that are in this building. Now that seems like a lot, but if you think about 80 years as a tree and a human lifespan, it is possible to regrow the volume of wood in this building in a single human's lifetime. And that's one of the important takeaways from this. So to wrap up, I think this is a beautiful diagram that this is created by the Building Green Council. And I think this is a really great kind of hierarchy of thought that aligns with structural poetics. Reuse to the extent we can what we have. And then when we do need to build new, that we are building optimized forms, elegant and efficient and economical structures, but that we're also choosing material that we can recreate and regrow. And this last slide, oops, sorry. This last slide is an image from a Tarkovsky film, one of my favorite films called Nostalgia. It's the final scene where the protagonist in the story, one of the protagonists in the story, is essentially keeping the faith and trying to keep this candle lit while he's walking across a very windy, abandoned in-ground pool. And just my closing thought here, in the mad rush of our society, the gravity of craft, slowness, attentiveness, appreciation can be an antidote. We don't need to build faster. We need an undergirding ethics of ecology, equity, efficiency, and economy, an ethics from which architecture can flow. Though these are but 5 words, there are endless permutations and iterations and aesthetic expressions that can flow from them. And if I could just close with a poem that's one of my favorites, by Denise Levertov. It's called Beginners. But we have only begun to love the earth. We have only begun to imagine the fullness of life. How could we tire of hope? So much is in bud. How can desire fail? We have only begun to imagine justice and mercy, only begun to envision how it might be to live as siblings with beast and flower, not as oppressors. Surely our river cannot already be hastening into the sea of non-being. Surely it cannot drag in the silt all that is innocent. Not yet, not yet. There is too much broken that must be mended, too much hurt we have done to each other that cannot yet be forgiven. We have only begun to know the power that is in us if we would join our solitudes in the communion of struggle. So much is unfolding that must complete its gesture. So much is in bud. Thank you. That's what I've got today. Appreciate your attention and listening.
Justin, thank you so very much. I admire your ability to cross between disciplines and translate language, numbers, thoughts in a way that is so beautiful to follow and think along with you. And the hope, that comes with it. I would love to open it up to questions. Our residents will lead that. From our attendees, feel free to use the Q&A, use the chat. We're monitoring both. Thank you, Justin.
You're welcome. Thank you.
Hi, Justin. Thanks so much for your presentation. It was really insightful. I feel really inspired and also happy that this is an ongoing conversation within the built world. Kind of curious about the Amherst project a bit more. I'm a visual artist, so I'm not really sure exactly how common it is for people to look at the original foundation and build upon that. I was really taken by kind of taking apart this building, locating it in some ways its skeleton, and being informed then to kind of create.
Yeah, I think there is, it's a great responsibility to take material from the earth and put it into a work of architecture or work of art. And I don't feel that regardless of the building's form or its history, every building has the potential to be revitalized. And we put a lot of creativity and energy in the creation of new forms, and there's a lot of excitement in that. I've been part of many of those discussions and amazing projects. But should that be our primary focus? I think that I think your cat agrees that we need to think about how we can better use what we already have. And there's a lot of joy and ingenuity and creativity that comes with that. Their histories, material brings with it its history, its provenance, and that includes there's a reason architects use the word vernacular every other sentence, right? There is language of constructed details, language of prior designs, language of local resources, right? So when we demolish a building, we are killing off a language, so to speak. And if we think about buildings from that lens, and if we respect not just the materials, but the ingenuity perhaps that went into that building and respect it in that way, I think people also want to, like, there is the lived experience that these materials carry. And when you are in a historic place, um, where human history has unfolded, you can feel that, right? If you're in a place where something terrible happens, you can sense that, perhaps metaphysically or sensorially in some way. If you're in a kind of sacred space, you sense that too. And humans, and so it's a really important part of human history and the perpetuation of human history. It's a connection to the past, really, too. So it's important on multiple levels, I think. I do a lot of work in New York City, and we've been adaptively reusing buildings. On August 1st, I'll be a structural engineer for 19 years. Um, our firm has been doing adaptive reuse projects since 1966. We can tell you that firmly that there are engineering solutions to adaptively reuse almost any kind of building. It just takes the will and the concerted effort and dedication to do it.
Thanks so much.
Thanks for your question. Yeah.
Hi, Justin. I really appreciated you being generous enough to share the sketches that go behind the details. Especially because I think people only are exposed to the final kind of polished versions of those. I guess I'm curious. I had a similar question with our previous speaker a few days ago, Victoria Vesna, who was more of like a technological, visual, and installation based artist. And I asked her what projects, I guess, what projects is it important to show or expose the technology or that those complicated systems that go behind a project? And I think I have a similar question um, for you as like a engineer, but also designer of these very intricate systems. Where do you, I guess, what is your thoughts on how people can experience those or don't experience those in a building?
That's a good question, Roy. I would say if somebody were to consider cladding a tree, it would be a travesty, right? Um, Obviously, I'm biased here because I'm a structural engineer, and there is this one aspect of me that takes a little bit of pride in our work being concealed and feeling like I have secret knowledge of what's happening behind finishes. But that gets overridden by, I think the importance of expressing the complexity of construction and structural systems is just one part of that. I love seeing how buildings operate and function throughout their life. And I think there's a desire to conceal structure because a lot of it, as a result of kind of the prefabricated nature of mass production of elements, it's not maybe that exciting for most people to look at. But if you were to consider crafting a detail, optimizing a material, an individual element for the forces that it's seeing, optimizing and crafting a detail to represent the flow forces through the building a bit more accurately, then there's kind of that's where the elegance gets involved and the craft can get involved. And then there's more of a natural desire to express things. This part why I'm such a big proponent of mass timber, and I want to focus that in this discussion, is it's a beautiful natural texture, and there are biophilic benefits, mental and physical health benefits that are derived from being in a space with exposed timber and other natural materials, where you can see that texture. Now, if you take a mass timber building and then you don't coordinate well with your structural and mechanical engineers, then that expressed timber is going to be partially concealed behind like a rat's nest of conduits and ductwork and haphazard structural layout. So that's where the collaboration and integration comes into play. If you approach it in an integrated manner from day one, the whole team has buy-in because the whole team's work is going to be expressed. And I just feel like hiding our work behind drywall, I know it serves its purpose for fireproofing and fire protection reasons, but it just kind of feels like a cop-out.
Thank you.
Not to mention it adds a lot of embodied carbon to our buildings, sometimes unnecessarily.
Justin, there are two questions in the Q&A by Jason Kim. Would you like to read it out loud and answer?
Sure, yeah. Can I see the...
Do you see it under the Q&A? Would you like us to read it for you?
Yeah, I can read it. Yeah, thanks, Jason. I'm glad you could join. Appreciate it. Let's see. I'll skip the wonderful lecture part. No, it's great that you have such a high level of care for the collaboration with architects and everyone involved, but I found that isn't always the case. What advice do you have if I'm working with a structural engineer who may not share the same level of collaboration or care in the design process? That's the first question. Well, that's a good question. I guess I'm biased now and say we should work together. But I fully understand that there may be plenty of scenarios where that isn't your call or your decision to make. And I want to be able to have opportunities like this to speak genuinely about my own passion for the built and natural world. Really, those two things are the same. My passion for architecture. And I look for opportunities to kind of infuse that passion in others. And I would say, like, seeking out the right trusted team members for the right projects. I would hope every project can be aspirational, right? I don't believe in this divide between, kind of rote, say, developer type projects versus like aspirational design projects. I think there's structural poetics could be stretched over any of that. I feel like a lot of that conversation or the lack of kind of engagement flows out of our model of cost, right? To be passionate, to share more ideas, to be kind of slow and build and craft a building, it takes more time and it takes more effort and it takes more attention. And we live in a world where those things are constrained, right? We use the phrase time is money everywhere. You hear that phrase, right? And I don't really know how to reckon with those things. But I do think resonance of ideas is one way to kind of drive a wedge into that conversation. And I would say, Jason, it's perhaps a question with the owner about what's important to you on the projects collectively, and make it known to the person who's perhaps paying the bills, whether that's the taxpayer and a civic or public agency or a private client, to make it known like this is what we need to create a beautiful project. And that also flows out of alignment of expectation and ambition for a project from the start, right? So that when you're choosing and selecting an architect, a contractor, or key subconsultants, that you're choosing consultants that align with the expectations for a project. So that would be an attempt to try and answer that first question. And then the second is mass timber the only option for new structures to lower carbon footprint and utilize renewable resources, or are there other systems that you see on the rise? The answer is definitely not sorry. The answer is there are alternatives. I think it will take time for building codes and regulatory bodies to catch up, but you are seeing more and more hybrid structures with, say, load-bearing bio-based material like straw, load-bearing straw elements. Paul Lewis in Princeton is doing a lot of research, and I know the architect Henning Larsson's doing a lot of work with bio-based materials, in particular straw, which is abundant, is a byproduct of current agricultural trends, and is fast growing. Bamboo is a fast-growing timber-like element, and there's a lot of built architecture, especially where bamboo is more prevalent in the world. Most of the temporary scaffolding in half of the world, eastern half of the world, is built with bamboo, and there are many beautiful works of architecture. And there are emerging technologies of laminating bamboo together to create products, glulam-like products, beams and slabs and so forth out of bamboo. So those are just some new emerging bio-based materials. I say new with kind of air quotes there, I guess, because those materials to some degree have been used in buildings for quite some time. And then the last component for that is that there are still structures where concrete's not going away, right? It's still a remarkable material, especially when it's used in combination with steel reinforcement, because it can handle tension and compression really well in that combination. Steel is a remarkable material with its strength to weight ratio. But if we're to use these materials, I think one of the key challenges that we have as an industry, and I'm excited about the potential for this, is how we design and detail those materials so that they can more readily be reused, so that we can take steel beams, unbolt them from one building and put them in another building, or reconfigure a building to suit the changing needs of a given community or a given building over time. I look at all these super tall cast-in-place concrete high-rises in Manhattan where I'm working, and I think about what the future of those buildings are. They are optimized buildings, but they can't readily be converted into a different occupancy type. Not very easily, anyway, because it's all a poured-in-place system for the most part. Whereas a steel-framed building could potentially be unbolted and reconfigured a little bit more easily. And there are ways to do that with concrete, with prefabricated concrete. This is an exciting realm where that we need to explore more, but there is a lot to explore, and there's a lot of creativity and ingenuity that can be applied to that.
Justin, can I ask you a brief question then, just kind of on that same sort of theme? I just was wondering, this is just kind of my own thoughts and something that I just have an interest in, so it doesn't need to be I don't know, a long answer, but talking about reusing and talking about all these new biomaterials, but what about there's been some development in post-tension stone, especially, over in Europe, and Webb Yates engineers are some of the main uh, group working on that. I'm not sure, if you have opinions or thoughts on that, if you think that that's a better direction to move over the concrete, or. Yeah, I'm just curious what you think.
It's a great direction. Yes, we've collaborated with Web8s and had lots of good conversations with them, and their work with pre-stressed and post-tension stone is really exciting and fascinating. The reason why stone is better than cast in place concrete from an ecological standpoint is that um, the creation of cast in place concrete requires a lot of energy. To create cement, you're extracting materials from the earth. Those materials are finite. Obviously, stone is finite too, but you're extracting those materials from the earth. That takes energy. You're combining them and heating them up to create slag in a furnace. That furnace, by and large, is still fueled with fossil fuels, and they require really high temperatures, right? Then that cement is mixed with aggregate. That also requires energy and more heat. And then it's transported to the site, usually with trucks that are fossil fueled, pumped into place with another fossil fueled element, and so forth. So you understand that there's a lot of embodied energy in the process. Stone is substantially less embodied energy because you're essentially extracting it from the earth and you're not really manipulating it too much. Maybe you're drilling holes in it for high strength steel cables. Of course, those steel cables have their own embodied energy. That's part of the process, but it's substantially less in that instance. Obviously, there are other logistical challenges of working with stone and limitations, but I'm excited about what Web8s has done. And I mean, there's a whole precedent of amazing architecture that is built on stone throughout the world that is still standing. So there's great durability.
Yeah, great. Thank you.
Justin, tell us a little bit more about your creative process when it comes to writing. I assume that when you think about structural engineering, deep observation matters a lot, and looking at systems that are around us and how they function. How do you think about poetry or composing a piece of poetry?
I Many of the poems that I wrote in my book Welcome Center were postcards that I sent to family and friends during COVID when I couldn't see them. And a lot of those were born out of a single word or phrase. I essentially walk around with a small notebook at any point in time, and either through observation or through a light bulb going off, suddenly I hear or see a particular word or a phrase that just strikes me different, even though I may have heard that word or spoken that word many times. So usually it starts with kind of a mysterious phrase, and then I build around that, or sometimes connect the dots between two of those things. So for me, it's actually very sonic oriented. Saying the word out loud sometimes peels back a layer and allows you to see a word. I think, I don't know if this will be a title of a future book, but when I was writing some notes on this presentation, I wrote down when I was writing a note on kind of ecology. I don't think I said this in the lecture, but I wrote down the thought, the phrase light touch. And I said, maybe that's a title for a future book. Even though we say, oh, we want this work of architecture to have a light touch. And I was like, wow, that can just take so many different meanings. It's a verb, it's a description, it's a way of being. So that's I guess a recent example. So it usually starts from that, and then I think I write my best poems when I have a person in mind or a group of people in mind on the other end of that. So I try and connect the dot between this mysterious phrase that intrigues me and an audience or recipient in mind. And a lot of surprising kind of twists and turns emerge from trying to connect those dots. And usually the poem is nothing like what I anticipated it might be by the time it's done, if a poem is ever really done.
Do you think that poetry helped you to unlock some problems or situations that happen through the process of engineering while you're working?
I do, and I think that's part of the I say magic maybe for lack of a better word, but there's for a long time, we're often told these are two separate sides of your brain. You have a left brain and you have a right brain. And I understand to a degree that's true, but it's a lot more, the border is a lot more porous than we give it credit for. And for a long period of time, I always loved writing. And then over time, that kind of got morphed into poetry specifically. But I always treated the writing aspect of who I was as something distinct from the engineering aspect of who I was. And around 2019, 2020, basically when some of these projects were starting off, the Amherst project and the Franklin and Marshall project, and I'd say Stephen Hull's thoughts on integration of poetry and architecture were also an influence in the quote unquote magic started happen when I flipped the question and I said, stop asking how poetry and engineering are different from each other and start asking how they are similar. And essentially a whole course curriculum, the course that I teach at Cooper, emerged from that. And you got a smattering of some of those ideas in a condensed form. But it changed a lot. And the big thing that it changed was it added another level of why was I doing what I was doing? Why spend so much time being a structural engineer? Why expend so much energy and care about creating a work of architecture? I found joy early on in my career in solving the technical challenges, and there are many, especially with Stephen's projects. Um, and there's a certain level of joy and satisfaction in doing that. But then getting a level beneath that, which one of my engineering mentors, Bob Silman, who started the firm that I worked for in 1966, this was his essential question. What ought we be doing, or ought we build this? And I had never come across that question in my engineering curriculum or my engineering career until Bob Silman gave a presentation at lunchtime in our office and says, I teach this class on philosophy to architects. And here's the essential question. And I have architects reading Martin Heidegger about like the philosophical basis for creating architecture. And I was like, whoa, you can think like that? Because I had never thought like that. And I'd never been trained to question why. And perhaps there are reasons, I would say not malicious reasons necessarily, but just I loved putting all of that in a blender and flipping the question. And it really changed, it really helped me kind of like name or label or be able to speak a little bit more about the type of projects I wanted to work on and the types of projects I wanted to deliver. And that doesn't always happen. Like there are a lot of projects that I work on that have great technical challenges, but it's a mansion for a rich person, right? But I take those technical lessons and challenges and then able to apply it to a project like Brooklyn Public Library. And I meant to tell this story, but I was a little wary of running out of time. But if you all still have a little bit of time, there was a Saturday morning in December when the design, those renderings that I showed of the New Lots Library, were to be revealed to the community for the first time. And there was a Saturday morning. There was essentially kind of a big ceremony. There was some spoken word poetry by people in the community, some musical performances. Some of the politicians who had worked really hard to get a beautiful building, a beautiful work of civic architecture funded in a community that doesn't typically see that public works of architecture that are this thoughtful and beautiful. And their thoughts and their ideas went into this project too. So they were going to see this project for the first time. And the junior architect for Mass, Demario Walker Brown, was to give the presentation and basically flash up the first renderings on the screen. And he's a young Black architect, and he talked very beautifully about his own experience and how libraries, I believe he's from Cincinnati, how libraries were an integral part in inspiring him to be an architect, and they were kind of a refuge. So with that backdrop, he unveiled the first rendering, and I was just kind of in the back row, standing behind the scenes, trying to take this all in. And everybody's in folding chairs. Everybody jumped out of the folding chairs. Folding chairs were falling backwards. There was a standing ovation, and it was amazing. It's one of the highlights of my career to see that. So it's architecture can be that too.
Thank you so very, very, very much, Justin. I think that's a beautiful place to end and keep thinking forward. Thank you very much for all your thoughts and the discussion with our panel. Looking forward to more conversations, Justin.
Thank you all. Appreciate
Thank you very, very
spending
much.
some time.
Thank you so much.
All right.